Welcome to Spaceverse, your portal to cosmic adventures. The James Webb Telescope has been captivating us with stunning images from space for the past 2 years, showcasing the vastness and complexity of the universe. As the most powerful space telescope ever constructed, it has been delving into the universe's deepest and oldest mysteries, revealing phenomena that challenge our understanding of cosmic history. This exploration has not only yielded groundbreaking discoveries for astronomers, but has also presented a series of intriguing questions that invite us to rethink our place in the cosmos. For instance, consider the existence of galaxies that, according to our current understanding of astrophysics, shouldn't even be there. How can it be that these distant cosmic giants are slumbering in the dark expanses of the universe? Furthermore, we are faced with the perplexing issue of the Hubble constant, a value that measures the universe's expansion rate. The measurements obtained by the Webb telescope do not align with our existing models, leaving experts scratching their heads and desperately searching for answers. This discrepancy raises profound questions about our understanding of the fundamental laws of physics. Fortunately, the James Webb Telescope is uniquely equipped to uncover not just the most puzzling mysteries of space, but also its breathtaking beauty. The stunning visuals it captures serve as a constant reminder of how small we truly are in the grand scheme of things. Humans often like to describe themselves as the crown of creation, an assertion that carries a certain pride. However, whether we accept this somewhat grand title is ultimately a personal choice. What is undeniable, though, is that when it comes to identifying the most remarkable creators of the universe, the honor is clearly due to forces beyond our understanding. It's essential to clarify that the James Webb Telescope hasn't unveiled any ominous power responsible for the cosmos's creation. Instead, it has teamed up with the Hubble telescope to provide an unprecedented combined view of one of the most famous images in modern space exploration, the Pillars of Creation. These towering, glowing structures are located approximately 7,000 light-years away in the Eagle Nebula within an open star cluster. They represent a stellar nursery, a place where new stars are born, and were first captured in stunning detail by the Hubble Space Telescope. The Pillars of Creation are not just visually striking, they are also a testament to the incredible processes that shape our universe. The gas and dust within these pillars are the raw materials for star formation, and as such, they play a crucial role in the ongoing cycle of cosmic evolution. The James Webb Telescope, with its advanced capabilities, allows us to observe these structures in new ways, revealing intricate details and shedding light on the processes that govern stellar birth and evolution. Stellar life begins in dense, cool clouds of gas and dust. When these gas clumps collapse under their own gravity, a protostar is formed. This young star first attracts matter from its immediate surroundings, gradually accumulating the necessary mess. Once it reaches a critical point, it can ignite hydrogen fusion in its core and transform into a fully fledged star. Interestingly, stars don't often develop in isolation. They typically form in groups or clusters, such as the magnificent Pillars of Creation. While the iconic Hubble Cosmic Snapshot from 1995 beautifully captures the overwhelming structure in the visible spectrum, the James Webb Telescope has taken the exploration a step further by examining it in the infrared. This innovative approach allows us to peer through the cosmic dust and gas that often obscures our view, revealing a whole new dimension of celestial wonders. The combination of these two images, one showcasing the visible light and the other focusing on the infrared, provides us with entirely new insights into this breathtaking formation, where the finger-like projections of the Pillars of Creation stretch across the cosmos, reaching lengths that are even larger than our entire solar system. Within the dusty cocoons of the Pillars of Creation, countless newborn protostars and stars lie dormant, quietly forming and waiting for their moment to shine. These young celestial bodies are hidden from view in the thick dust, but their presence is felt in the cosmic dance of light and energy. The intense radiation and stellar winds emitted by these emerging stars have carved out vast cavities in the surrounding dust, giving the structure its distinctive and awe-inspiring appearance. It's a dynamic and evolving landscape that tells the story of stellar birth and evolution, reminding us of the continuous cycle of creation in the universe. Given this spectacular sight, it's no surprise that the Pillars of Creation were among the first subjects explored by the James Webb Telescope in 2022. NASA has since combined the images captured by both Hubble and Webb to unveil even more intricate details of this cosmic marvel. The infrared images reveal hidden stellar infants and cool gas components that were previously obscured, while the visible light captures the scorching, glowing gases produced in the stellar forge. This collaboration between two of the most powerful telescopes ever created not only enhances our understanding of the pillars of creation, but also inspires a sense of wonder about the vast and mysterious universe we inhabit. What's even more exciting is that this remarkable spectacle is not just presented as still images, but also as a captivating video. When you watch the corresponding clip, you embark on an exhilarating journey through the three-dimensional pillars of creation. The perspective shifts between visible and infrared light, highlighting the importance of exploring different aspects of the same structure using multiple space telescopes. This multifaceted approach allows us to deepen our understanding of these celestial phenomena and appreciate the complexities of stellar formation in a way that single observations simply cannot capture. The stunning family portrait of stars recently captured by the James Webb Telescope in the Serpent Nebula is just as captivating as the combined view of the pillars of creation. Located 1,300 light-years away, this image reveals a stellar nursery, specifically a reflection nebula. Unlike other nebulae, reflection nebulae do not emit their own light. Instead, they are illuminated solely by the light of nearby stars. In the past, these nebulae posed significant challenges for earlier telescopes, but Webb's NIRCam can penetrate the dust and gas to reveal details that have long been hidden from our view. In the stunning images captured by the James Webb Telescope, the gas and dust are rendered in vibrant hues of orange, red, and blue, creating a mesmerizing color that highlights the dynamic environment of star formation. Amid this colorful backdrop, countless young stars shine brightly, their radiant light piercing through the dense clouds of cosmic material. Some of these brilliant celestial bodies are merely 100,000 years old, a relatively brief period in the grand timeline of the universe. This means they are still in their early stages of development in astronomical terms, akin to infants in a cosmic nursery. Despite their youth, these stars are on a trajectory that will eventually lead them to possess masses similar to that of our Sun, illuminating the cosmos with their warmth and energy as they mature. One particularly notable aspect of this captivating star family portrait is the flame-like structures found in the upper left corner, which resemble massive shreds or billowing tendrils of light. These striking features are not mere visual artifacts, they are remnants of gas and radiation outflows from young stars that are just beginning their journeys into adulthood. Previously, in earlier images taken by other telescopes, these outflows had been captured as indistinct spots, often blending into the surrounding material or remaining completely unseen due to the limitations of the technology at that time. The revelation of these features offers a deeper understanding of the complex processes at play in stellar nurseries. The outflows represent powerful jets of material ejected by young stars, a phenomenon that occurs as they accumulate mass and energy. As these jets interact with the surrounding gas and dust, they carve out channels and shapes that not only shape the immediate environment, but also play a crucial role in the ongoing process of star formation. This intricate dance of creation illustrates the dynamic nature of the universe, where chaos and beauty coexist. Moreover, these flame-like structures serve as a testament to the power of advanced observational technology like that of the James Webb Telescope. By capturing these previously hidden details, we gain insights into the life cycle of stars and the conditions that foster their birth. Each vivid image tells a story of transformation and evolution, highlighting the interplay of forces that govern the cosmos. As we delve deeper into these cosmic phenomena, we are continually reminded of the grandeur and complexity of the universe, as well as our insatiable curiosity to understand its many mysteries. NASA has likened these protostellar outflows to snowflakes drifting from the sky during a heavy storm. This image is significant because it is the first to demonstrate that all the outflows are oriented in the same direction. While these may appear to us as mere structures moving from the upper left to the lower right of the images, they hold crucial research implications for astronomers. This visual evidence supports the theory that young stars typically rotate in the same direction as their gaseous birth envelopes collapse. What's the deal with the black bars at the bottom left and top right of the image? Did NASA use a sensor pen to obscure a couple of UFOs? Unfortunately, it's not that thrilling. Those black rectangles simply indicate areas where data is missing. In more exciting news, we now have the first photo of a super Jupiter. and the count of known exoplanets has reached 6,911 in 4,941 systems. The number of planetary worlds orbiting stars other than our Sun is increasing almost daily, with researchers adding a variety of unusual celestial bodies to our star maps. For instance, there's the gas giant HD 189733b, located just 63 light-years away, which, according to recent findings, has a scent akin to rotten eggs. While this may sound odd or amusing, it actually represents the first evidence of hydrogen sulfide on an exoplanet. Moreover, scientists have demonstrated their keen observational skills by identifying a range of nearby exoplanets, some of which are Earth-sized and potentially habitable. In particular, K218b has been in the spotlight for several months, as this celestial body is thought to be a true ocean world where life could already be present. Webb's near-infrared spectrometer NIRSpec detected potential biosignatures, including spectral signatures of methane, carbon dioxide, and dimethyl sulfide. MS is produced on Earth by marine plankton and during the breakdown of organic matter, serving as a primary source of atmospheric sulfur and contributing to the characteristic smell of the ocean. However, interpreting the DMS signal on K218b is another matter. The signal wasn't particularly strong in the Webb data and only became apparent when the data sets were analyzed in a specific way. So until we fully understand the implications of this exciting discovery, some patience is needed. However, a snapshot taken by Webb in an entirely different location presents a different situation. Despite the numerous exoplanets already discovered, images of these distant worlds remain relatively scarce. Most available images primarily feature young, hot gas giants, which appear as bright spots in the infrared spectrum. However, there's been a remarkable breakthrough. Just a few weeks ago, Elizabeth Matthews and her team from the Max Planck Institute for Astronomy in Heidelberg succeeded in directly imaging a cold, older exoplanet for the first time. The groundwork for this achievement was laid by studying the triple star system Epsilon Indi, located a mere 12 light-years away. This cosmic trio consists of two brown dwarfs and the orange dwarf star Epsilon Indiae. Previous spectral analyses had hinted at the presence of a large planetary companion, but it wasn't until an analysis with Webb's MIRI spectrograph that researchers confirmed the existence of the exoplanet. Interestingly, this exoplanet was found in a location quite different from earlier studies, which had significantly underestimated both its mass and orbit. In essence, we are dealing with a celestial body that qualifies as a super Jupiter. To put this into perspective, Jupiter, the largest planet in our solar system, has a diameter of about 140,000 kilometers and a mass equivalent to 318 Earth masses. In contrast, the bright point of light detected in the images of Epsilon Indi is likely around 6 times the mass of Jupiter. Named Epsilon Indiae-b, this massive exoplanet orbits its host star, Epsilon Indiae, in a relatively eccentric orbit, with its farthest distance being roughly comparable to the distance between the Sun and Neptune. As a result of its unique orbital characteristics, this super Jupiter takes an impressive 200 years to complete a single orbit around its star. In fact, it was this eccentric orbit that clarified the unexpected discrepancies found in earlier observations. Researchers had initially detected the planet at its closest point to the star and mistakenly assumed it followed a circular orbit. The new analysis not only corrected the orbit, but also revealed various characteristics of the exoplanet. For instance, the average temperature here hovers around 0 degrees Celsius, and at approximately 3.5 billion years old, this gas giant is far from being a young planet. Out of the 25 or so exoplanets that have been directly imaged so far, all of them were less than 500 million years old, with the majority being under 100 million years. In this context, Epsilon Indi-b stands out as not only the coldest but also the oldest exoplanet ever directly imaged. The stunning images captured are not just visually appealing to scientists. They also present significant opportunities for gaining new insights. Aged exoplanets like this one are ideal for testing our models of planetary development and acquiring new information about the later stages of distant worlds. However, Epsilon Indiae-b still holds some intriguing mysteries. It appears that certain wavelengths of its radiation are being absorbed, likely due to clouds in the gas giant's atmosphere. Potential chemical culprits could include compounds like methane, carbon dioxide, and carbon monoxide. Fortunately, researchers are already planning to investigate these phenomena, and barring any unforeseen complications, they expect to soon uncover the true reasons behind the reduced radiation flux. And that's it. Thank you for exploring the wonders of the cosmos with us here at Spaceverse. From the breathtaking images of the pillars of creation to the groundbreaking discovery of the ancient super-Jupiter Epsilon India-B, we've delved into the mysteries and marvels of our universe. Remember, there's always more to discover, so be sure to subscribe and join our journey as we uncover the secrets of space together. Until next time, keep looking up